My name is Ofer Maor, and I will talk to you today about security automation, security test automation as part of the software development lifecycle. So a few words about myself. I do security strategy at Synopsys. How many people here have heard about Synopsys? Very little. So how many people have heard about Coverity? Similar. So Synopsys is actually a very large software company. We've traditionally been focused on chip design software, so that's why most of you have never heard about us. But in the last couple of years, we created a new business unit for security of software testing. We have a bunch of products. We acquired a bunch of companies, including my company, which is how I joined Synopsys. So worth getting to know us. That's the commercial plug. Now we can move forward. I've been doing security most of my life, all of my professional life. I've been doing application security since about 2000, when it was very uncommon to talk about it. I've had a chance to work from pretty much every side of the spectrum as a pen tester and a hacker and an application firewall, an application scanner, and code analyzer. I came up with a new technology for code analysis, which is called IAST. If you haven't heard about that, it's interesting to learn about that as well. That's what I do. In the last few years with my product with IAST, I've spent a lot of time helping organizations build security test automation into their development lifecycle, and with a strong focus on Agile, where automation is very big, and that's what we'll talk about today. I've been with OASP. OASP is part of this event. I've been with OASP since its inception in 2002. I've been the chapter leader for OASP Israel. I've been part of the OASP committees. So I'm also a really avid photographer, and I really like to one time stand at a podium and speak about my photos, but apparently that doesn't get accepted. So I have an Agile cheetah to go on with that. Okay, so let's go on. The Agile Security Challenge. So what is the Agile Security Challenge? So it may sound stupid, but it's really very similar to whatever challenges we have with normal software development, only in much shorter time frames. And while that sounds trivial, that creates new takes on these challenges. So the first thing we have with Agile is that we have very short cycles, right? We used to develop software over a year. Now we develop software over the course of 4 weeks, 3 weeks, 1 week, 1 day, 1 hour. I have customers that push hundreds of new features per day in continuous delivery. And they want to build that, test it for functionality, test it for security, and push that within hours. It's remarkable. It's amazing to see that. And a lot of things get compromised in the way, and we'll talk about that. So we have very short cycles, and as a result, it's very hard to plug security in, right? And the security people, we are outsiders to the development process. And that doesn't work when it's very short cycles, right? If it takes us, I'm not even talking about continuous delivery, but if it takes us a week to build, test, and deliver a new software, security people will become a bottleneck. And so we have to have security done by developers. And we've tried that for a lot of years, right? And it's not really working great for us. So we'll talk about today how we can make that work to some extent. And it's the only solution. We have to let security be handled by developers. And the problem is that developers don't necessarily understand the problem, or they don't. And I know we will all promote security training, and I'll talk about that later. But realistically, and trust me, I love training. I love security training for developers. I think everybody should train their developers for security all the time. But it's not a full solution. They will not become experts. We all know that developers change their jobs every 6 to 18 months. And yeah, that's life now. And we just can't really make them security experts. And they're having a hard time prioritizing risks. So one of the problems, and we all know that with security, and as we start security testing, is that we get too much data. We get too many findings, too many problems, too many potential problems, too many risks, and we want the developers to take control of that and prioritize that, and that's not going to happen because they can't do that. So all this is creating a new set of challenges that we need to resolve. And to resolve that, we need automation. And I will come back to this word a lot of times during my talk today. But realistically, everything that's happening in an agile development lifecycle needs to be fully automated. If we need people in the process, it's a fail. If we say, oh, it's just this little thing here that will go through a security guy, it's a fail. Because we will become a bottleneck. Because it's amazing how much of this is going on every day that we just can't hire enough people to give an answer to that. So we need a solution that's fully automated. We need a solution that's continuous. It can work all the time together with the rest of the development lifecycle, which is continuous today in the agile world. And we need it to be practical. And this is a big thing. And practical is hard for security people. We tend to be very perfectionist, right? Everything needs to be great. There was a talk, how many of you were here in the previous talk about threat modeling? Just a bunch. But it was a good talk because we have to know what we focus on. Because realistically, and as we go to rapid development, even more so, we're not going to fix everything. We are going to go live to production with vulnerabilities. And that's fine, as long as we know which vulnerabilities and we can live with them for a certain amount of time. And we have compensating controls, of course. So what I'm going to do with you now is go over 3 customers that we have that we've worked with to build a program like that. And I'm not going to talk about our product too much, but more about the process and what we've done there. And there are 3 different cases, because the first case is of a very immature company in terms of both agile and security. And the third case is of a very mature. And so we can see the differences. We can see what works everywhere. We can see what might not work in certain cases. And we're a small crowd, so feel free to ask me questions as we go along. You don't have to wait to the end. So, first case, insurance company. Medium-sized insurance company, not very big. Agile maturity, I say in transition, it was really low. When we came, they were just starting their agile transformation project. And this is a big word now. If you're consultants, if you go to customers, you will see that everybody's doing agile transformation. Everybody wants to be agile. And you go to these organizations that still have a 2-year waterfall process, and we're just getting ready to move to agile. And that is because their bosses heard that agile is good and told them to move to agile, but they don't have the right team. And so that's a big part of the challenge. Everybody wants to be agile. The majority of the big organizations are still struggling very hard with that. And as we try to give them solutions, we need to adapt to that. There's very few customers that are really agile. I'll talk about that later. But so these guys, they were very not agile. They had one project, which was their new agile project. And they came to us and say, we need a full solution for all our projects, which are all agile at some level, some being none. And they did understand security pretty well, because they're an insurance company. They've been doing pen testing for years. So that was the good side. But they had very little automation from the functionality perspective, and we'll talk about it in a second. So a lot of homegrown apps. They have about a few dozens of applications they develop internally or through outsourcing, but they own the code and IP. We're targeting 15 systems. Some are customer-facing, some are agent-facing, some internal. As I said, varying level of maturity in terms of agile. With some, again, the lead project had full continuous integration, everything automated, and test automation. Others, nothing really. Maybe a continuous integration server, but still a very slow process. And luckily, they wanted the focus to be on the new system, the new architecture, which was good for us, although over time, as they saw they're transitioning a lot slower than they wanted, they changed the process to fit some of the older technologies. So what were the challenges? So the first challenge was no security background for developers. That's always the case. And we keep it this way. The second challenge, as I said, different agile maturity. We couldn't have one process that fits all, but we tried to create a lot of flexibility. The third problem was that there was insufficient test automation from a functionality perspective. Now, when we do security testing, we like to see what the application is doing from a functionality perspective. If you don't have test automation, that makes it harder to introduce security test automation. There are not environments for that. There's no scripts to record and so on. So they had very limited test automation, and they had very limited security resources. So we're talking about a medium-sized insurance company that have 5 people in the security department. Not the application security department, the security department, right? So firewalls, policies, application security, all that was 5 people. Probably not so many resources to help the process. And of course, being that they're an insurance company, a lot of regulation that they need to meet and live with. To top it all, they use a lot of different technologies. Again, it's very common for every large enterprises. Java, .NET, mainframe, a bunch of other things. So the first thing we did when we came over was to work on the process with them, right? Because bringing just the technology that does testing is great, but it will not help you. So the first thing we helped was to facilitate the cooperation between the R&D and security. And you'll see that with all my cases. So I mentioned this before. If you want to do Agile, and you want to do rapid development, and you want to do security in there, you have to get the developers, or some part of the developers, like the DevOps, to take ownership of the security. And if you're getting a lot of pushback from them, then this is what you need to solve before anything else. You cannot deliver software quickly without somebody inside the development organization owning security. It will just not work. And I've seen a lot of that. So the first thing, we got them on board. Luckily, the lady that was heading their whole DevOps and Agile transformation efforts was very cooperative. She was very happy to take ownership on that. She felt like that's part of what would make the difference. And we got her on board. The second thing was, while we did that, was to make sure that the security people don't feel like they're losing control, right? We're security people. We have to be in control. That's who we are. And we are now giving the security responsibility to somebody else that's not measured by security, and it's not, their butt on the line if they get hacked. So we had to make sure that we stay with security visibility, and I'll talk about that from the technical perspective in a minute. And we created a weekly approval committee. Why? Basically, even their Agile is just fairly Agile, 3-4 week sprints. We're not talking continuous delivery here. So they said, we build a policy which says what is good or bad in principle, but once a week we meet, we look at the results from all the different projects, and if you want to go live, the security has to approve that as part of that committee. So that's not fully automated, I know. But again, we adapt. And it works fairly well. They came to trust the system over the time, and now it's just a good way of discussing with security and things we're not sure about. We did R&D training. That was part of the project, but it was very basic. The point was not to teach the developers how to be security experts, because they will not. It was more of an awareness training. It's like, there is this thing called application security. So you'd be amazed. We go to this insurance company. We're training about 150 developers. And I'm asking, how many people here have heard about SQL injection? And less than a third of the people in the room raised their hand. Yes, that was a year and a half ago, not 10 years ago. So that's still the situation. So we gave them basic training, get to know, SQL injection, cross-site scripting. There is this thing called application security. We're introducing a new solution, a new product that will give you results that you'll need to take care of. It's important. And we created a risk policy, right? So we sat down with them, and essentially there were two parts to this. One part was we need to make sure what, from your perspective, makes sense to go live with and not to go live with. And they said, well, at the point we're at, where we still have a lot of problems and we want to move forward, we don't want to break the build too much. So anything high or critical, we don't go live. But all the mediums and lows, we can live with those. And it's fair enough. The other part of that was that they looked at what our product does in terms of saying, well, this is high, this is low, this is medium, and they changed half of it. And so we needed to provide them with a way to edit the risk levels that the product produces, because certain things that from our perspective might be considered medium would be a violation of regulation for them, and so they needed to change it. And so we created this policy, and essentially with this policy we're able to say, we can live with that. Of course, we have to fix it later, and we'll talk about it in a second. We can live with that. We can't live with that, and we can control that. And the last part was they wanted multiple output channels. What do we mean by that? So we have this product, it finds vulnerabilities, and different people in their organization want to consume this differently. So we have one output that goes to developers, that goes through the bug tracking system. We have another output that goes to security through PDF reports, and so on and so on. So in terms of technologies, they had Jenkins as their continuous integration. That's probably by far the most popular build server out there. Takes code from all the Java and .NET repositories, builds it, runs the test automation, then runs the security automation. They had ticket tracking with HP Quality Center, so basically their bug system. So one of the things that we strongly believe in, if you want to have developers be part of the process, you need to speak in developer language. And the first thing is, how do you feed the data to them? And developers, they have a very clear mode of operation. They write code for some time, and they fix bugs for the rest of the time. Okay? And they fix bugs that come through the ticketing. In some more advanced organizations, everything comes through the ticketing, not just the bugs, but also the requirements. And so if you try to push a new way, like reports or a new user interface for the security system, to give them the feed of what they need to do in security, you're confusing them. You're making them work in a way that's not natural for them. And they will push back. They don't like security, right? Developers don't like security. They don't feel like it's helping them because they need to deliver functionality on time, and that just takes more time. So at least we need to help them. So we integrate into ticketing systems. So they had HP. They had some static analysis for quality, some open source static analysis. That was actually not integrated into the process because it had too many false positives, and that's not easy to work with in an automated environment. And then whenever they created a new build, they deployed that build into their test environment and ran their test automation, which again wasn't fully covered, and did a whole bunch of manual testing on that ongoing throughout the sprint. So how did we integrate? So we integrated to launch from the Jenkins. So whenever a new build is created, after test automation takes place, security automation takes place. And we integrated with both automated speed and manual testing. And now this is important. If you have full test automation, and you never have full test automation. People say they have full test automation, but they don't really. But if you have almost full test automation, then it's very good to run security testing as part of that, right? You can see what test automation is doing and then run security test automation on top of that. But if you don't have test automation and you'll try to run your security test automation off that, you'll have coverage problems because your test automation only tests 10% of your app, and what about the rest? And so what we did was we actually integrated so we see the manual testing, and we can later replay that. So we would actually automatically replay their manual testing as test automation because they didn't have enough test automation on their own. So we merged everything we saw from the automated manual testing, and we ran that every day. And then, as I said, we created multiple outputs. So there were a few outputs. So the first output was a build breaker. So when you create a build in Jenkins, right, you create the build, and then you can run a bunch of scripts. And if they return a certain output, you can script the Jenkins to say, this build is broken, right, because it didn't compile, or it compiled, but it didn't pass basic sanity. And so if it doesn't pass basic security sanity, meaning it has high or critical findings, the build will break. And that's a big deal if you're a developer. Developers don't like to break builds, right? So if a developer introduces a new vulnerability, the build breaks, and all the findings that are found are pushed into the bug tracking system where they can be fixed. So the ones that are higher critical, because they break the build, they become blockers, you have to fix them before you can release the product. The rest of them go into the queue, into the backlog of bugs, and they will be remediated after a certain amount of time. They get in the mix with the rest of the bugs. We didn't prioritize medium or lower security bugs, were not prioritized over other bugs, right? Because functionality bugs is also a risk for an organization. And as I said, we created a PDF report that was sent to the security so they can look at it before their weekly committees. So that's a screenshot of, that doesn't work. That's a screenshot of how this looks. Basically a bunch of systems. All the ones that are in green are ones that are fine, meaning they work, they build, there was nothing that broke the build. The one in red is broken, meaning it has a critical finding in it. And this can be managed. You can click into that. This is the Jenkins UI, right? It's not our UI. It's the Jenkins UI. Everything's there. Everything's represented there together with all the non-security. Yes? Right. From the build perspective, if I'm the build manager, this means that this build has passed. So it may still have vulnerabilities, but nothing of very, higher critical severity. So they are pushed into the bug tracking system, and they're flagged with a security flag. So the security people, as part of that, they gave them credentials to the bug tracking system. They can get reports of all the security bugs, like any other type of bug. And you have a weekly report of bugs, how many bugs are over a month old, blah, 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 the whole thing. And again, it has to be created in levels, because otherwise we'll not be able to work. Okay. We're good. So case number 2. So this was a really interesting case. This actually earlier, about 2.5 years ago, we started working with them. UK retailer, agile maturity very high. So one of the things you'll notice is that everybody that does e-commerce is very agile. And that is because Amazon is killing everybody. Amazon is extremely agile. They keep changing their website. Amazon works in continuous delivery amazingly. And I met a bunch of retailers that were through their agile transition process and said, it's horrible. Amazon comes out with this new feature. We want to have something similar. It takes us a year because we're waterfall. So they've all transitioned to agile. And these guys, they were very agile. It's probably one of the best agile shops I've seen. Very, very mature, but at the same time, very immature from a security perspective. So they actually reached out to us because they got hacked through some SQL injection. We talked to them. Apparently, they hire this pen testing company to do a pen test once a year. Apparently, it was a very bad company because we ran our product, I mean, just very superficial, and found a bunch of SQL injections, cross-site scripting, nothing fancy, just the run-of-the-mill vulnerabilities, and obviously they got hacked. And so they came to do this. So they're a UK retailer with a very large e-commerce platform that has different flavors, so they have different brands. So it's one technology, but different brands. And as I said, 3-week sprints, very strict enforcement. So this was really cool about these guys. They did Scrum to the letter. And so they had 3-week sprints. The last automation ran on, they would deliver on Mondays. The last automation would run Saturday, Sunday. If something failed on Saturday, Sunday, it was pulled out of the build Monday morning before the build was sent. There was no, we'll deliver it Tuesday. No. If it's not ready, it's out. And they enforce it really well. So their security maturity, as I said, was very low. They had 2 people in the security department. And that included the store physical security. So the guy that ran the security was ex-police. Very nice guy, but not into computer stuff at all. He had another guy under him that did all the computer stuff. So obviously they had a lot of challenges here. And so obviously, again, their developers had no security background and so on. However, again, we were lucky. The guy who was owning the application that got hacked became personally interested in fixing that. And so we got development cooperativity again. They had nothing before we came, nothing in terms of security in the development, threat modeling, secure design, nothing, zero. They've been just doing their functionality stuff. And the 3-week sprint at first seemed like a very strict thing to live with from a security perspective, but it actually proved pretty well. So again, we got R&D to support us. Really, they drove the thing. If in the previous company, security drove it and R&D came on board, this was driven by R&D. They were concerned about their applications. Security said, yeah, we think we need to do that, but they simply didn't have the resources. We created a security workflow. They had a lot of test automation. In fact, they had almost everything had test automation, and they wanted to limit the number of environments that they use all the time, so they didn't want to run security automation every day because they wanted to maximize the functionality automation. So eventually we agreed to run security automation once a week. So inside their 3-week sprints, they had each week was a mini sprint, and at the end of each week they would run security tests. So weeks 1 and 2 generally is where they built functionality. And week 3 was the week where they fixed everything. And so at the end of week 1 and at the end of week 2, we would run security tests on new code. And the week 3 test, again, the weekend before the release, had to verify that there were no issues. And again, very strict. If there was an issue, a security issue that was above the threshold, which was medium or higher for them, they would not include that in the build. They would remove the feature because that feature was vulnerable. And so that made us very nervous when we came in, because that means that security will cause features not to be on time. And as you know, this can make people nervous. But because we had the support of the R&D and because they had an incident just shortly before, it worked. Everybody was on board. It still works. It became their culture, and they now understand it's been over 2 years that they're working this way. And again, there's weekly reports in PDF for the security people. Again, they're not involved in the process at all, but they want the audit and the control, at least from a liability standpoint. So again, Jenkins for CI, Jira for their ticketing, doesn't really matter. But what was interesting is that all their testing infrastructure was in the cloud. And it was not a static testing infrastructure. So it wouldn't be like, well, here's your server, this is what we test, you push a new version, we test it. No. Every time they create a new build, they spin new Amazon machines and deploy the products to them. Then they deploy all their testing scripts to them and everything to them. When I met them first time, that was pretty innovative, novel. Today, we have a lot of customers that do that. Orchestration has become big, and it's actually fantastic because, at first we were a little nervous. How would we deploy our product automatically every time? But realistically, it really helped us because once we realized that their app is pretty big and it requires resources and they don't want to disrupt their existing automation, we simply use their scripts to create a new environment on Amazon that is the security testing environment. And so it's easy to replicate testing environments and get what you need. So every week they spin a new environment just for security testing, which means we can do as rigorous testing as we want. We don't need to do any optimizations. I think it runs for about 6 hours to do the full test of their app, which is fine because it's on a new, completely clean environment. Everything's automatically deployed. They deploy their artifacts. They deploy their functionality testing. We record the functionality testing and then deploy those onto the security testing. So we integrated with their Selenium, which is what they use for functionality testing, so we can learn all that data. And then again, everything can break builds. There's HTML reports on top of the Jenkins view and the bug tracking system, partly for security, partly for project management from the development side that wants to get that through the report and the PDF reports. So they actually scripted these HTML reports on top of our product. That's not, we don't do that. That's just results from the command line, which they scripted with the colors. So every Jenkins build, you can click and get this from the Jenkins UI, which just gives a highlight of the results. So it's not just a failure or pass. And you can get all the reports backwards for every day. So you just log into that portal they created, and you get all the results. You click it, and you see everything. And of course, you can get to the full report, PDF report, and everything you want. They've been working like this for over 2 years now, and very happy. The process works. They find vulnerabilities once in a while, and you know. Questions? No. Okay. So the third case, and as we're progressing, third case is a very large e-commerce, not Amazon, but very large e-commerce. You would definitely know the name if I told it to you. They were very mature. They're very large. We're talking hundreds of developers. One of the largest e-commerce sites in the world. Again, they were big, legacy. They've been doing Agile transformation for 4 years now. And they're still about half and half. They still have about half their site on their old infrastructure and half on their new Agile infrastructure. They have a very advanced Agile DevOps infrastructure. They actually acquired a company specializing in that just to get that process rolling. And it's a very big site. So it's a modular site. It has multiple front-end and back-end components done by different teams. We'll get to that later, but when we find things, we need to be able to tell who's the owner for everything. Hundreds of engineers, development, QA, DevOps. So it's a big shop to go into, and they're very heavily invested in security. So as we came in, they were already using static analysis, dynamic analysis, pen testing, code reviews, everything. And they wanted another layer. They wanted another layer in automation as part of QA. And the reason they wanted it was because they had a bunch of static analyzers and code review processes, but they also had something running in production, black box scanner in production that keeps running regularly. And it found something. It found a cross-site scripting. And they were very unhappy because they have all this process in place to prevent vulnerabilities for getting to their production site. And yet something was found. And from their perspective, the only reason they run the black box scanner on the production site is because it needs to show them that they're clean. And so they realized that the static analysis process that they had was not perfect. And they still use it, but it's not perfect. And part of the reason that it was not perfect is because static analysis sometimes generates false positives. And so you need to be very, when you do fast development, you need to be a little light on what you actually consider as verified. And so something fell in between the cracks. And so they wanted to introduce another security testing layer in the QA test automation phase, and that's how we came to meet them. So multiple components by multiple teams, as I said, they need the ability so the way our product works, it tests the entire application. But when I find a problem and I open a bug for it, it needs to be opened on the right component. Because otherwise we need a person to allocate those to the specific components. And if it's a person, then it's not automated. And if it's not automated, it becomes a bottleneck and it doesn't work anymore. Very dynamic testing environment. Everything is orchestrated automatically, a little bit like our previous customer, but more so. So homegrown DevOps. So here's the thing. If you're a very large retailer, you have a problem putting all your stuff on Amazon because they are your #1 competitor. If you're a small retailer, it's fine. But if you're a very large retailer, even though Amazon is a separate silo, Amazon Web Services. And so they built everything, well, acquired, but they had their own everything, their own cloud, their own CI, their own test automation, their own everything. Nothing was supported or known technologies to us before that. And highly agile, rapid environment with continuous delivery. So we're not talking about sprints anymore. We're talking about daily artifacts, new code being pushed into production every day, which is, where the world's going. In 5 years, we'll be looking back at people who don't do daily artifacts. Really? You only release code once a week? And again, because it's a daily process, security cannot be involved. I'm kind of repeating myself, but it's really all about that. So process was initiated by the security group, as I said, because of this incident. It's not an incident. They weren't hacked. They were just unhappy about finding something in production. They got DevOps on board. That happened before we came. We gave them training to the QA and DevOps, but the training was not about security. It was not about how to create secure code or how to do security testing. It was training about the process of including security test automation inside their existing test manual and automated test. And they wanted security tests to be part of other testing. If you remember with my previous customer, they did it as a separate once a week thing on a dedicated environment. Here, they wanted it included inside the test. And the reason was because, as I said, with rapid development, we can't test the whole application all the time. We just have to test the changes or the new features or the new functionality. And so that has to be in line with whatever they're doing from their test automation for functionality, because that's already synced with what they're doing. Again, medium or higher blocks, especially, and this is especially important when you do automated continuous delivery, right? Because whatever doesn't block the build is pushed to production. If the build doesn't break, it's pushed to production. It's an automated process. Like with the 3-week sprints, the actual push to production, somebody signs it off with a click. But in here, it's all automated. Somebody checks in the new code, all the tests gets done. If all the tests come back clean or clean to the level that we agreed on, it's pushed to production. And of course, it's not pushed to 100% production. It's usually pushed to 10% with A/B testing, but still, it's out there. So from our side, as a vendor, as we came in there, what they said was once we deploy that POC, we run it for a few months, we want to make sure that it comes clean. Meaning we never, ever, ever see in production again something. For the time being, we're good. The security group supervises the process, has visibility to reports again, but is not part of the process. So as I said, they have their homegrown CI orchestration cloud. The only thing they used, which was standardized, was Jira, which was good. So they create a new build every day, and they create a new set of environments every day. And one of the challenges is that the environments don't look the same every day. So let's say, their environment's built out of a couple of dozen of servers, and let's say that now they've improved the search functionality. So they would create more servers of the test component in the test environment so they can test for performance and run their full test automation quickly enough. And then the next day, they added something with a cart, so there will be another server that has more instances. So everything is created dynamically. Terrifying process. And then they orchestrate the new builds and all their test automation. So when there's a new feature, they have new test automation scripts, and everything is orchestrated in a way that tells which script should run. So they have test automation for everything, but they can't run test automation on every build, because their full regression test automation, not talking security, just functionality, takes about 12 to 18 hours. It's a big application. Even though they have over 10 servers, it's a big application to test. So they can't do that every day because 18 hours, that takes most of the day. And so they only run what's changed. And then, of course, there's a separate process on the side that does regular full regression tests, but it's not in the pipeline of the continuous delivery. And so hybrid automation, they call it. Basically, they have Selenium for whatever is at the web front end, and they have their homegrown stuff for everything that's web services, even though Selenium supports web services, but they wrote their own stuff. So we spent a lot of time with them building their orchestration to support the deployment of our product as part of their elastic variable orchestration. And so now every server that they deployed, at least in the systems that we've already deployed into, gets on with our stuff on it, and everything's fully automated. We don't see that. So that we can support it. It's on their regular testing environments. So when they run their existing functionality test automation, it's dormant, but it's still there. Everything is there. We did, of course, full CI integration. And we directed all the functionality test automation to go through our product so we can see them, so we can know what functionality is currently being tested. So we monitor their test automation, and based on that, we know what we need to test, because they define as part of their process that the test automation runs only on the things that have changed or new in the system. And so by monitoring their test automation, we can tell what needs to have security tests on it and not test the whole system. And so the security tests run daily right after the functionality testing. Again, full Jira bug tracking integration. As I said, we created a specialized custom feature for them where we were able to define, based on class paths, which part of the application belongs to which team. And so as we open the bug, it goes directly to the relevant organization. And so after it's done, they run their black box tool in production to make sure that it's clean. So, questions? They are, yeah. Okay. If you want to ask me offline, I can talk about my product. Our product can do that. The black box scanner obviously doesn't do that. I think black box scanning, especially on production, has a lot of limitations, and it's not their main security measure. It's just their final verification process. It's just that, you know, there's this, I won't mention names, but it's a big SaaS-based black box scanning company, and they run it regularly just to make sure nothing slipped between the cracks. And they understand it's not perfect, which is why they have static analysis and runtime analysis and all the process in place. It's just another layer. And I agree, it mostly looks at the more technical injection, cross-site scripting type of vulnerabilities. More questions? No, so our product, my product, is doing runtime code analysis, so it instruments the code and sees how it's running. And so it has certain advantages over static analysis for this type of testing, but it can also be done with static analysis, assuming you have the right technology that doesn't produce false positives. So and again, I really don't want to go into specific products and vendors. There are some products that you could use. There are other products that unfortunately are not very optimized for that. So when I created my product, I was very focused on creating something that developers can use. There are other products, some of the earlier static analyzers in the industry that may not be so developer friendly and are more geared towards usage by security people. And in that case, it will be difficult to implement a process like that with those tools. Well, thank you very much for your time. I know it's late, part of the day. So